Question 5. Janine wants to have helium-filled balloons delivered to the home of a sick friend. Each balloon costs $4 and delivery cost is $5. And then we're supposed to make a chart to show the cost of 1, 2, 3, 4 balloons. Maybe I'll rewrite that. Let's call this the number of balloons. I can't write it all in there. And this is the total cost. Okay, and we have 1 balloon, 2 balloon, 3 balloons, 4 balloons. We actually can't figure out the total cost yet until you really read the question carefully. And we're going to end up kind of making an input-output machine here. Alright, to figure it out, so I'm going to start off by drawing my template of an input-output machine. And now we have to read the question really carefully to figure out, well, what is really happening here? So each balloon costs $4. So without much thinking, I can realize that, well, that means that the first operation is going to be times 4. Because for 1 balloon, it's $4. The second part of the machine will be the delivery cost. The delivery cost is $5. And that's not $5 for each balloon. That's $5 just to deliver any amount of balloons. So if Janine actually only orders 1 balloon, it's going to cost her $5 as a delivery cost. If she orders 100 balloons, the delivery cost is still going to be the same. It will be the $5. So that's a plus 5 in our machine. Okay, so now we can figure out the total cost. So 1 times 4 is $4, and you add the $5 in. So that means it would cost $9 to have 1 balloon delivered. Pretty expensive. If you have 2 balloons times $4 is $8, and $8 plus 5 is $13. So the cost of 2 balloons is $13. 3 balloons, 3 times 4 is 12, and 12 plus 5 is 17. 4 balloon cost, 4 times 4 is 16, and 16 plus 5 is 21. So you can see that the inputs are going up by 4 each time. And let's fill in our chart. 17, 21. What is the pattern rule that relates the number of balloons to the total cost? Well, the number of balloons is the input, and the total cost is the output. So this isn't a different kind of question. It's just got a couple different words to represent input and output. So now that we kind of understand that, we can write our pattern rule. Look at the machine. What the first operation in the machine is multiply. That's the first word of our sentence. Multiply the input. And if you put balloons down here instead of inputs, that's okay. Okay, that's no problem. Multiply the number of balloons by 4. Then add 5. The expression is just looking at our machine and coming up with a mathematical expression. So the way to do it is look at the first operation. It's times 4. Well, the expression, you put the 4 first. And then we have to come up with a letter to represent the number of balloons. Well, let's go with B. B for balloons. And then the last operation is plus 5. That's our expression. 4b plus 5. And what if I had 9 balloons? How could I check my answer? Well, I could extend my chart. I don't really have room for it. Or I could use the expression. Either way is going to work. For me, the simplest way is to use the expression. So I start with the original expression, 4b plus 5. And then instead of putting a b I put down the number that B represents. Well, B in this case would be 9. 9 balloons. That's the input. The number of balloons is 9. 4 times 9. And then I put a plus 5. And then to finish it off, I then do the multiplying first. 4 times 9. More powerful than adding, so I got to do the multiplying first. 4 times 9 is 36. And 36 plus 5. The last number then, you're going to say it equals 41. 36 plus 5 is 41. So the cost is $41.00.